Let's take a look at another squeeze theorem example. We have evaluate limit as x approaches 0 of secant of x minus 1 over x. Now you might be thinking, how is this squeeze theorem? This has secant in it. And the problem is the two theorems that we learned using the squeeze theorem don't have secant in it. Well, consider this. Secant and cosine are closely related. They're reciprocals of each other. So that's a good indication, and plus it looks a lot like the 1 minus cosine, right? Except it's secant minus 1. So perhaps we can use the squeeze theorem to find this limit. So let's follow the same steps we did in example 1. It says to, step 1, rewrite function using trigonometric identities. And we know that secant is 1 over cosine. So we're going to go ahead and replace secant with 1 over cosine. There is no other identity for secant of x minus 1, so we just have to use this reciprocal identity. So since these two things are equal to each other, then their limits are equal. So limit as x approaches 0, we're going to try to find now of 1 over cosine minus 1 over x. Now I want you to see the top here. We want to combine these, right? We always want to combine two terms on the top of a fraction. So we're going to write 1 as cosine over cosine. Okay, so it's 1 is 1 over 1, right? And then it's cosine over cosine. So we get 1 minus cosine over cosine over x. Now you can start to probably see why this is heading towards the squeeze theorem. So what we're going to do is multiply this by 1 over x. And so now we have 1 minus cosine x over x times cosine. And now we can start to see the special case squeeze theorem coming through. Step 3 is to isolate the special case. So we can see, if we go back here, we do have a 1 minus cosine of x over x, which is one of the squeeze theorem components we learned. So we're going to break this up into 1 minus cosine of x over x times 1 over cosine, like so. And we've already proven that the limit as x approaches 0 of 1 minus cosine of x over x is equal to 0. Okay, that's the second component we learned. Okay, so our next step is to break up the limit. So this is limit as x approaches 0 of 1 minus cosine of x over x times the limit as x approaches 0 of 1 over cosine of x. Again, that's a product rule for limits. The product of the limits is equal to the limit of products. All right, step 5 is to evaluate. We've already shown, I like to use colors here. We've already shown that this is equal to 0. Again, the other one is sine of x over x is 1. 1 minus cosine of x over x is equal to 0. And look, it won't matter what this is, right? Because it's 0 times that. Anyway, this one's going to be 1, right? Because if we plug in 0 for cosine, if we plug in 0 for x, we get cosine of 0, which is 1. 1 over 1 is 1. So you get 0 times 1, which is 0. So there it is, folks. We've just proven that the limit as x approaches 0 of secant of x minus 1 over x is equal to 0. I'll kind of go back through and step back through some of our steps here. We basically just used a trig identity, and then we used the squeeze theorem to then break up the limit and evaluate it to get 0. Let's take a look at the graph to confirm our result. Here we have our function secant of x minus 1 over x. And as you can see, the limit as x approaches 0 from the left and right is equal to 0. That's it for this example. If you have any other questions about it, let me know.